Have you ever thought why soap bubbles are spherical? And have you ever seen a cubical soap bubble floating? Of course not. We always think about them as a childish game. They are actually useful to explain mathematical and physical theories. One of them concerns their form, and therefore we are going to discover the reason why soap bubbles are spheres. The thin spherical film is made of attracting particles. The molecules of the liquid attract each other, giving rise to a stable liquid phase. The forces acting on the molecules of the two bubble surfaces are different from those acting on particles inside the bubble. The particles inside are completely surrounded by the other particles, and attractive forces are directed in all directions. And consequently, the sum is zero. There is a net inward force acting on the surface particles. Increasing the liquid surface requires energy, and for a liquid it is energetically advantageous to have the minimum surface. In order to reach energetical stability, particles from the surface, if possible, move to the center, so that the external surface is as minimal as possible. Let's find out what is this mysterious shape. For a value of the area, the polygon which presents the minimal perimeter is the one which has the maximum number of sides. The more we add sides to our polygon, the more it is similar to a circumference, which can be approximated to a polygon with infinitive number of sides. For this reason, the circle is the minimal surface defined by a line of fixed length. The results we found for the d-dimensional space can be applied in the three-dimensional space. Volume, the solid with the minimal surface is the sphere. And I want to stress it is the best energetical condition the liquid film can reach. There is another particular behavior we are going to explain: the iridescent and changing colors of soap bubbles floating through the air. Bubble surface there is a rainbow, we could say, but the beautiful colors reflected by the bubble surface are produced by a different physical mechanism, which is called interference, and it's typical of wave propagation. But what is interference and why light interferes? First of all, light is a wave. A wave is a phenomenon that can be described with this equation. Wavelength. A is the amplitude. Interference is produced by the superposing of two or more waves. If the two wave crests are perfectly superposed, the resultant wave has the maximum amplitude, and it's called constructive interference. Instead, if the crest of the first wave is aligned to the throat of the second wave, the result is a destructive interference. Talking about lights, to the constructive interference corresponds the maximum brightness, while to the destructive interference corresponds darkness. characterize different colors. This is what we see on soap bubble surface, considering it as a film. Considering a ray of light which arrives on the bubble surface, in part it is reflected, and in part it is transmitted into the bubble until he meets once again the surface. Here is another time reflected and transmitted. The two reflected rays, which are parallel, produce the interference. Interference depends on the distance covered by the two waves and, as a consequence, on the depth of the film. We see different colors because each wavelength interferes constructively and destructively in different points of the surface. If the bubble moves, points of constructive and destructive interference change. As a result, we see different colors on the same bubble. We have the same results if we observe a static bubble while we are changing our position. Are you surprised? Look how physics can be funny.